Hi, how are you? Our learning target for this video is I can find trigonometric ratios given two sides of a right triangle. Okay, so for the warm-up, I want you to label the hypotenuse of the right triangle that you're looking at here and the sides opposite and adjacent to theta. So theta is this Greek letter right over here. So theta comes from the Greek alphabet. So the hypotenuse is the side across from the right angle. So this would be the hypotenuse. And the hypotenuse is also the longest side of a right triangle. So you can find the hypotenuse by looking across from the right angle. The opposite side is across from theta. So here is theta. Go across from it and you'll find the opposite side. The adjacent side is next to theta. So the adjacent side would be here. So to summarize, the opposite side is across from theta. So across from theta. And the adjacent side is next to theta. Okay, so the 6 trigonometric ratios. Let's begin with 3 of them. So there are 6 that you have to remember. Let's look at the first 3. Sine of theta, cosine of theta, and tan of theta. Nice way to remember the formulas for these trigonometric ratios is to remember SOHCAHTOA. So SOH stands for the sine of theta is equal to the opposite side over the hypotenuse side. CAH stands for the cosine of theta is equal to the adjacent side over the hypotenuse side. And the tangent of theta, TOA, TOA, stands for the tan of theta is equal to the opposite side over the adjacent side. So those are 3 trigonometric ratios, but I told you there are 6 of them. The other 3 are called cosecant of theta, secant of theta, and cotangent of theta. Cosecant, secant, and cotangent are reciprocals of sine, cosine, and tangent, respectively. So cosecant of theta is the reciprocal of the sine of theta. So the cosecant of theta is the hypotenuse over the opposite side. So you just have to flip sine to get cosecant. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it's adjacent over opposite. So you just have to flip tangent and you get cotangent. Example 1. Given the triangle below, express in simplest form the 6 trigonometric ratios in relation to theta. So let's begin with the first 3, sine, cosine, and tangent. And we could use our mnemonic device, SOHCAHTOA, to remember the formulas. The sine of theta is equal to the opposite side over the hypotenuse side. So it would be the opposite side, which is this missing side here, over the hypotenuse. So the problem we run into is that we don't have the opposite side of theta, so we have to find it. Since this is a right triangle, we can use Pythagorean theorem to find the missing side. So we use Pythagorean theorem, a squared plus b squared equals c squared. We solve for one of the legs. Subtract 9 on both sides. You get b squared equals 7. Square root both sides. b is equal to radical 7. So the missing side is radical 7. So what's the sine of theta? It's the opposite over the hypotenuse, so it's radical 7 over 4. The cosine of theta is the adjacent side over the hypotenuse, so the adjacent side to theta is 3, so the cosine of theta is 3 over 4. The tan of theta is the opposite over the adjacent. So the opposite side is radical 7, the adjacent side is 3, so the tan of theta is radical 7 over 3. Now these should be easy to get, cosecant, secant, and cotangent, once you have sine, cosine, and tangent, because they're just reciprocals of sine, cosine, and tangent. So the reciprocal of radical 7 over 4 is 4 over radical 7. The reciprocal of 3 over 4 gives us 4 over 3, and the secant of theta, which is 4 over 3. We flip radical 7 over 3 to get the cotangent of theta, and we get 3 over radical 7. But these answers are not in simplest form, and they have to be in simplest form. Why do I say they're not in simplest form? It's because you have a radical in the denominator for cosecant of theta here and the cotangent of theta here. So you have to rationalize the denominators. Okay, so let's do that. That means we have to multiply the numerator and the denominator by the radical in the denominator. So we have to multiply the numerator by radical 7 and the denominator by radical 7. And that's going to give us 4 radical 7 over 7. This is fine. There's no radical in the denominator, so you just leave it like that. This one you have to rationalize. So multiply the numerator by radical 7, multiply the denominator by radical 7, and you get 3 radical 7 over 7. Again, we're doing this because we cannot have a radical in the denominator, because that's not considered simplest form. Okay, let's go back to the previous slide. So these are the values that we had before we rationalized, and after we rationalize we get these values. So the sine of theta is radical 7 over 4, cosine of theta is 3 over 4, this is tangent of theta, and then these are our values for cosecant of theta, secant of theta, and cotangent of theta after we rationalize. Example 2, given the cosine of theta is radical 5 over 3, find the cotangent of theta. So if the cosine of theta is equal to radical 5 over 3, they are in essence giving us the adjacent side and the hypotenuse. So our right triangle should look like this. By the way, why did I say they're giving us the adjacent side and the hypotenuse? Well, that's because the cosine of theta is adjacent over hypotenuse. Let me erase that sine of theta. We don't need that. So the adjacent side is, so let's just put theta anywhere. Doesn't matter. We'll say this is theta. And the adjacent side is radical 5 and the hypotenuse is 3. So use Pythagorean theorem to find the other side. So I'm not going to go through the Pythagorean theorem for finding the other side. I'll just say it's 2, but you should definitely check out how I got 2. And if you don't understand how I got 2, you should ask in the comment section. Okay, so we are asked to find the cotangent of theta. Well, we know that cotangent is the reciprocal of tangent. So the tangent is equal to opposite over adjacent, which means that the tangent is going to be equal to 2 over radical 5. So what would the cotangent be equal to? Well, the cotangent of theta is the reciprocal of tangent. That would be adjacent over hypotenuse, which is radical 5 over 2. And that's our final answer. Radical 5 over 2. Okay, I hope this video helps. Take care.